Center of gravity or centroid is our today's topic. So what is center of gravity or centroid? Basically, centroid is the center point of an object. The point at which length, area, and volume is supposed to be concentrated is known as centroid or center of gravity. In fact, it indicates the center of mass of a uniform solid. It has many real-life applications like lots of construction applications as well as engineering applications to design structural members, to calculate stress and strain, and also energy. We need to figure out, or we need to locate the centroid of an object to stabilize that structural member or that object. Before starting or going to the examples, when we are asked to locate the centroid of a rectangular object, we can easily locate that. That means, as the rectangular objects are symmetric with respect to x and y axis, that means this rectangular object is symmetric with respect to x and y axis. This x and y axis basically forms the global coordinate system. So as this all the rectangular shapes are symmetric with respect to x and y axis, that's why we can easily conclude that the centroid of a rectangular object or a square or a center or a circle is right at the midpoint of that objects. So if you are asked to calculate the center or centroid or the center of gravity of this rectangular section, which is of 2 meter width and 3 meter height, then you can easily locate the centroid of this object. What you need to do, firstly you need to set a global coordinate system, and then with respect to this 0, 0 point, that means which is the starting point, with respect to this 0, 0 point, we can easily conclude the centroid of this section. So for this section it will be right at the midpoint, which is, or for which the coordinate will be the value of x coordinate will be half of 2 meter, which is 1, and the value of y coordinate will be half of 3, which is 3 by 2 or 1.5. So this is the centroid of this rectangular object. So when we are asked to calculate or locate the centroid of a rectangular section or a square section or a circular section, then easily we can locate that. But in case of composite shapes or composite objects, we are required to calculate or locate the centroid using our some basics of determining the centroid of composite shape. So that is mainly our first example where we are asked to determine the location of centroid. So in this example 1, here we can see a composite shape which is basically a L section. So we need to locate the centroid of this L section. In order to do that, the first and foremost step is we need to divide those composite shape into smaller segments. We need to divide those into segments which we can easily determine the centroids. So here we can see a L section. This L section is comprising of 2 rectangular sections. Whether we can consider these 2 segments as segment 1, this segment, and another one as this one, these 2 segments, or we can also consider it as segment 1 and another segment over here. So anyone we can consider. So let's see how we will be able to locate the centroid of this composite shape or this L section. So the first step that we have already mentioned is to divide our composite shape into the segments for which we can easily determine the centroids. So we had already divided it into two segments. Let's consider it segment 1 and this one as segment 2. So according to our first step, we had divided it into two segments, and our second step is to set the reference coordinate. Let's set the reference coordinate. For this example, let's consider the coordinate system over here. That means this is starting or the 0, 0 point. This is our x-axis and this is our y-axis. So our second step is to set the coordinate system. And now our third step is to locate the center point of each of the segments with respect to this coordinate system that we had considered over here. So with respect to this x and y axis we are considering over here, now we need to locate the centroid of segment 1 and segment 2. So for segment 1, the coordinate or the coordinate of centroid will be almost over here. So the segment 1 has a width of 2 inch and a height of 12 inch. So in order to reach to the centroid, we need to start from 0, 0 point, and along x direction we need to travel a distance of half of 2, which is 1, and along y direction we need to travel a distance of half of 12, which is 6. So the coordinate will be half of 2 is 1, and along y-axis we need to travel or we need to move half of 12, which is 6. So this is basically for segment 1. That's why let's denote it with x1 and this one is y1. As we are moving in x direction, so 1 unit, so this is x1, and along y direction this is 6, so let's consider it as y1. Now we need to do the same thing for segment 2. For segment 2, we need to locate the centroid. This segment 2 is starting from this point, so starting from 0, 0, firstly you need to move 2 inch along x-axis, and then there will be the starting of segment 2. In order to move to the centroid, we need to move along x-axis about half of 8, as the width of this segment 2 is 8 and the height is 2 inch. So starting from 0, 0, firstly you need to move 2 inch, and then after that half of 8, which is 4. So in total 2 plus half of 8, which is 4, in total it will be 6. And along y-axis we need to move, so let's consider this is the center point, so along y-axis we need to move half of 2 inch, which is 1. So this is basically the coordinate of segment 2. Let's denote it with x2 and y2. So we had already got x1 y1 x2 y2. As we can see here, only two segments, so that's all to determine the centroids of each of the segments. Now we need to calculate area of each of the segments. So for segment 1, the area, let's denote it with A1. The area will be 2 inch times 8 12 inch, which is 2 times 12 means 24. And for segment 2, it will be 2 times 8, denoting it with A2. The area will be 2 times 8, which is 16. So we have got A1 A2 x1 y1 x2 y2. Now applying the formula, as we can see that this composite section is basically the addition of segment 1 and segment 2. That's why while applying the formula, in order to calculate the centroid of the full section, we need to add up, use the addition sign in the formula. Let's see the formula first. While calculating x bar, which is the centroid of the whole segment or the whole section consisting of segment 1 and segment 2, so the centroid of this full section is denoted with x bar and y bar. We need to determine or calculate the value of x bar and y bar. So the formula to calculate x bar is equal to x1 a1 plus x2 a2 divided by a1 plus a2. As we can see here, only two segments, that's why it has been considered as, or it has been written as x1 a1 plus x2 a2. If there would be three segments, then an additional term needs to be considered. If there would be 4 segments, then we need to consider 2 more segments or 2 more terms. So plugging the value of x1 a1 x2 a2 and a1 a2 in this formula, we will get the value of x bar, which is basically the coordinate x of whole segment at center point of this whole segment. So we can calculate the value of x bar, a1 x1 or x1 a1 plus x2 a2 divided by a1 plus a2. It will be about 3 inch. Now let's calculate the value of y bar. For y bar, the formula is almost the same, but in place of x1 we need to consider the values of y coordinates. That means a1 y1 plus a2 y2 divided by a1 plus a2. So plugging the values of a1 y1 a2 y2 a1 plus a2 that we had already determined earlier, the value of y1 is 6 and y2 is 1 and a1 24 a2 16. Plugging all those values, we will get the value of y bar as 4 inch. So we will have to conclude it as x bar equal to 3 and y bar equal to 4. So the value of x bar will be 3 and y bar will be 4. The coordinate is 3, 4. In this way we can calculate or locate the centroid of this L segment or L section. Now let's come to the example 2. In this example 2, we are asked to calculate the centroid of this T section. This T section can be divided into 2 small segments or 2 simpler segments. Segment 1, which is in blue color, and segment 2, which is in yellow color. Now firstly we need to set the reference axis. After dividing it into segments. So as we have already divided it into two segments, now let's set the coordinate system. We are setting the x coordinate at bottommost point and y coordinate at mid portion. So why are we considering this y coordinate at mid portion? Yes, we can consider it over here, starting from here as 0, 0, but while considering, or if we consider this y axis at mid portion or at mid of this section, then it becomes much more easier to locate the centroid, as the full segment or the full T section is symmetric with respect to y axis. That means the part which is available at right side of this y axis is exactly the same available at left of y axis. So as the right portion and left portions are equal, so that means this T section is symmetric with respect to y axis. But is it symmetric with respect to y axis? No, it is not symmetric with respect to y axis, because it is not symmetric with respect to x axis. If we want to draw the x axis at midpoint, we can see that the upper portion is bit higher considering to the comparing to the lower segment. So this is not symmetric with respect to y axis, but it with respect to x axis, but it is symmetric with respect to y axis. As we can see that we had already mentioned that with respect to y axis, the y axis is dividing this segment, this entire section into two segments, two equal segments. So as the y axis divides it into two equal segments, so this is actually symmetric with respect to y axis. And when an object or a section is symmetric about an axis, while considering the reference axis, we need to consider that particular axis at midpoint. So we had done the same thing over here. We are considering the y axis at midpoint. It will be much more easier to locate the centroid while we are considering the y axis at midpoint. Now we need to do the same thing we have done earlier. That means we need to locate the centroid of two of each segments that we had already divided into. That means we had divided it into segment 1 and segment 2. Now we need to locate the centroid of segment 1 with respect to this reference axis starting from 0, 0. So this is in the intersecting point of two axes, so this is the 0, 0 point. So starting from 0, 0 point, we need to locate the centroid of segment 1. As this is a rectangular segment, we can easily locate its centroid. So in order to calculate or determine the centroid, which can be denoted with x1, y1, as we are considering for segment 1, in order to locate this x1 and y1, we need to move along x and y axis. So what will be the value of x1 starting from 0, 0? As the 0, 0 is right at the mid portion, do we need to move along x-axis? No, we do not need to move along x-axis. This x-axis, the value, as we are not needing to move along x-axis, so the value of x1 will be 0, and to reach to that point, to this point, now we need to move along y-axis. How much amount do we need to move along y-axis? We need to move this amount, which is 12 plus half of 2, so 12 full 12 plus half of 2, which is 1. So 12 plus 1 is in total 13. In total 13. So the value of y1 will be 13. So for segment 1 we had located x1 and y1. Now for segment 2, let's consider this is the center of segment 2. This is the center of segment 2. In order to move to this segment, point, we need to move along x-axis? No, as we are starting from 0 0, this 0 0 starting from 0 0, we do not need to move along x-axis, we just need to move along y-axis to reach to this center point of segment 2. So here also the value of x2 y2, the value of x2 will be 0, and in order to move to this point from starting from 0 0, we need to move along y-axis. It will be half of this total height of segment 2. The total height is 12, so half of 12 is 6, so the value of y2 will be 6. Now calculating a1 is 2 times 10, which is 20, and a2 is 2.5 times 12, which is 30. Now we need to locate the centroid of the total section, total T section. We don't know where the centroid is locating at. Still we don't know the location of this centroid of this whole section, as this is a composite section. So let's calculate x bar and y bar, which is basically the coordinate of this centroid, or the centroid of this entire section. So x bar and y bar, applying the formula of x bar, which is a1 x1 plus a2 x2 divided by a1 plus a2. As the value of x2 is 0 and the value of x1 is 0, so the entire value or the overall value will be 0. The value of x bar will be 0. Now applying the formula of y bar, a1 y1 plus a2 y2 divided by a1 plus a2 or a1 plus a2, applying this formula, we will get the value, plugging the value of y1 as 13 and y2 as 6, plugging 13 and 6 and a1 a2 in this formula, we will get the value of y bar. So we can conclude x bar comma y bar equal to equivalent 0. The value of x bar is 0 and the value of y bar is 8.8. So x bar will be 0 and y bar will be 8.8. In this way we can conclude our answers to determine or to locate the centroid of a composite section. Now for example 3, this is a bit complex section. We can see that this section is comprising of 4 small segments in total. So what are the segments that it can be divided into? The segments are, let's consider this triangle. as section 1 or segment 1, this triangle, this right angle triangle, as segment 2, this is segment 3, and this quarter circle over here is segment 4. Let's denote the number: segment 1, segment 2, segment 3, and segment 4. Now calculating each of the coordinates, each of the center of these small segments, that means for this small segment, segment 1, if we can calculate its or locate its centroid, that means x1 comma y1, locating the centroid of segment 2 as, that means its coordinate x2 comma y2, for segment 3 x3 y3, and for segment 4 x4 y4, and then adding those up, applying the formula of x bar, which is x1 y1 plus x2 y2 plus x1 a1 plus x2 a2 plus x3 a3 plus x4 a4 divided by a1 plus a2 plus a3 plus a4. Applying this formula, plugging all those values of x1, x2, x3 and x4, we will get the value of x bar. Similarly, plugging the formula of y bar as a1 y1 plus a2 y2 plus a3 y3 plus a4 y4 divided by a1 plus a2 plus a3 plus a4, we will be able to calculate the value of y bar as well. So our first step is to divide it into smaller segments or simpler segments. We had already done it. Now we need to consider a reference axis along which, or with respect to which, we need to calculate the value of x1 y1, x2 y2, x3 y3 and x4 y4. So let's consider the reference axis right at this point. Let's consider it as 0, 0. This is x-axis and this is y-axis. So now to calculate the center of this first segment, which is segment 1, this segment 1 is a triangular section. So in fact this triangle is a right angle triangle. To locate the center of a right angle triangle, firstly we need to visualize the section. To calculate center or to locate center, that means let's denote it with x1 and y1. To calculate the value of x1 and y1, firstly we need to visualize the section. If we want to start from this point, so now starting from this point we need to move along x and y axis to find out the value of x1 and y1. So while moving x axis, how the section appears, so we can see that along x axis the entire section is increasing along x axis, and while we will be moving along y axis, the section along y axis is gradually decreasing. So along x axis it is a increasing one, and along y axis it is a decreasing one. If we want to start from this point, now so we need to locate this point. While starting from this point, if we find a section, if we find a section which is an increasing one along x-axis, then the x1, that means the value of the x coordinate, will be 2/3 of the total length along x-axis. That means here the total length, let's consider the total length along x-axis is b. That means the base is b, so the center will be lying at a distance of 2/3 of b. This will be the value of x1. And for y1, as along y-axis the segment or the entire section is decreasing, as this is decreasing along y-axis, to move along, while moving along y-axis, the value y1 will be equal to 1/3 of the total length along y-axis. Here the total length along y-axis, let's consider it as h, so it will be 1/3 of h. So while we are facing an increasing segment or increasing section while moving, then we need to consider it as 2/3 of b. And if we are facing decreasing segment, as if we can see the segment is the section is decreasing, on that case we need to consider 1/3 times the total length. Okay, so for this case, this is segment 1, we need to find the value of x1 and y1 first. So the total length along x-axis is given as 6. So along x-axis this segment 1 is increasing, so it will be 2/3 of 6, which is 4. So the value of x1 is 4. Now to calculate y1, we need to move along y-axis. So along y-axis the segment is decreasing, so while decreasing, facing a decreasing segment, it will be 1/3 into total length along that axis. So along y-axis the total length is 6 plus 3, which is 9. So 1/3 of 9, which is 3. So the value of y1 will be 3. Now our segment 2 is a rectangular segment. Starting from 0 0. For rectangular segment it is easier. The value of x2 will be 6 plus half of 12, which is 6. 6 plus 6 means x2 will be, starting from 0 0, firstly we need to move along x-axis, that means 6 plus this half of 12, 6 plus half of 12, which is 12. So the value of x2 will be 12, and the value of y2 will be half of total height of this rectangle, which is given as 6. So half of 6 is 3. So y2 will be 3. Now x3. So x3 is another, segment 3 is another right angle triangle. So now while moving along x-axis, we can see that the segment is decreasing along x-axis. That means we need to consider 1/3. So 1/3 of the total length along x-axis, the total length along x-axis is given as 12. So 1/3 of 12, 1/3 of 12, here the 1/3 of 12 will be 4, but this is not the starting point. Our starting point is 0, 0. So 6 plus 4, which will be 10. So the value of x3 will be 10, and along y-axis it will be 6 plus, as the segment is decreasing along y-axis, so it will be also 1/3 of 3. So 6 plus 1/3 of 3, which will be 7 in total. Now let's come to the fourth segment. Our fourth segment is a quarter circle. So to calculate this quarter circle, let's consider this is the quarter circle. If the radius of this circle, quarter circle, is r, means the radius of the total circle is r. So we need to move along x and y axis. If we want to start from this point, along x axis the total section is decreasing, and along y axis also the total section is decreasing. So while we are getting a decreasing one, when we are moving along x and y axis, decreasing, if the segment is section is decreasing, then the center will be lying. Let's denote it with x4 y4. On that case, the center will be lying at a distance of 4r by 3 pi. So if we consider the radius as 2, then it will be 4 times 2 divided by 3 pi. But in this example, the radius is given as 6, so it will be 4 times 6 divided by 3 pi. But this is not the starting point. As this 0 0 is the starting point, it will be 6 plus 12 plus 4 into 6 divided by 3 pi. So in total it will be 3 into 2, that means 8 divided by pi, 6 plus 12 plus 4 into 6 divided by 3 pi. In total it will be 20.54 inch. But while moving along y-axis, the segment is also decreasing. The segment is decreasing while moving along y-axis, so it will be 4r by 3 pi. It will be only 4 times 6 divided by 3 pi. So now we have already got x1, x2, x3 and x4, y1, y2, y3 and y4. Then plugging all those values in the formula of x bar and y bar, we will get the value of x bar and y bar, which is mainly the centroid of this composite section or composite shape. Here the answer of, or the coordinate of centroid of this entire segment will be 11.93, x bar equal to 11.93 and y bar equal to 3.41. So this example 5 is almost same as the previous one, which is example 3, but the main difference is this example 4 has a hollow section or a hollow portion on it, and the section is bit more irregular than the previous one. So let's see how we will be able to locate the centroid of this following shape. So according to our procedure that we had mentioned earlier, the first step is we need to divide the entire section into simpler segments. Like we want to consider this triangle as our first segment, and second segment we do want to consider is this entire rectangle. This is segment 2, and from this rectangle, if we can subtract this quarter circle and this circle, then we will get our mentioned section or mentioned segment. So in total, this is the figure. So similarly, we need to calculate x1, x2, x3 and x4, as we are considering 4 segments in total. So this is the center of the first segment, this is the center of second segment, which is the rectangular, the entire rectangle, this entire rectangle, and this is a third segment, which is a circular one, and our fourth segment, fourth segment is a quarter circle. So starting with our first segment and consider, let's set the reference axis over here. So this is our 0, 0 point. So we are setting our reference axis over here. With respect to this 0, 0 point, now we need to calculate the center of this first segment. Let's denote it with x1 and y1. So we can see, while moving along x-axis, the triangle, right angle triangle, is increasing. While considering the increasing segment, we need to consider 2/3 of the total length along x-axis. The total length along x-axis of this segment 1 is 6. So 2/3 of 6 will be 4. So x1 will be equal to 4, and then segment 2, let's denote it with x2, y2. What would be the value of x2? Starting from 0, we need to move along x-axis. Firstly, we need to travel a path of 6, and after that the total length along x-axis of this triangle is 4 plus 7 plus 5, which is 16. So half of 16 is 8. So 6 plus 8, 6 plus half of 16, or 6 plus 8, which is 14. And similarly, the value of y3, x3, which is the centroid of segment 3, the value of x3 will be 6 plus 4, which is 10. You can see the center of the circle is lying at a distance of 4 from this point. And for x4, which is the center coordinate of, which is the coordinate of segment 4, x4 and y4. So the value of x4 will be 4 plus 7, and after 7 we can see that total radius is 5. So while we are considering from here to here, that means in this direction, we know the formula is 4r by 3 pi. So in total, the x4 value will be 6 plus 16 minus 4r by 3 pi. Then we will be able to reach on this point. 6 plus 16 minus 4r by 3 pi, it is almost about 19.87. So we have got the value of x1, x2, x3 and x4. Similarly, we will also find the value of y1, y2, y3 and y4. And then we need to apply the formula of x bar and y bar. And in x bar and y bar, as we are subtracting this circle and this quarter circle from the entire segment that we have considered over here, so we need to denote the subtraction sign, denote it with subtraction sign instead of addition sign. So plugging the values of x1, x2, x3 and x4, a1, a2, a3 and a4, we will get the value as 11.58. So x bar equal to 11.58. Similarly, plugging the values of y1, y2, yn3 and y4, we will be getting the value of y bar as 5.08. So lastly, we will need to conclude x bar equal to 11.58 and y bar equal to 5.08. So basically, these 4 examples that we had shown in this lecture covers the total basics of Centroid, and I hope you will be able to solve any problem if you can understand these 4 examples very well.